Hi, my name is Marco, and I'm a tutor with the Academic Success Center at A&M. Today, I'll be going over a very common calculus problem that a lot of engineering students struggle with. So let me get into my tablet and show you the problem. Okay, so the problem reads, a tank of water in the shape of a cone is leaking water at a constant rate of 2 feet cubed per hour. The base radius is 5 feet and the head of the tank is 14 feet. At what rate is the depth of the water in the tank changing when the depth of the water is 6 feet? Okay, so here the very first step is identifying what you're being asked. The keyword here is rate. So we're being asked to find the rate of change of the height as the water goes down. So this. The concept this problem is testing is related rates. So what we need to do is somehow relate the changing height of the water to some other rate of change we know. In this case, it's the volume, and we know that it's 2 feet cubed per hour. Now, if we look at this equation here, the equation of the volume of the tank, we see that it relates volume and height, but it also has radius, which also has a rate of change, which we don't know. So we want to get rid of this. And to do so, we can simply rewrite the radius in terms of height using this relationship here. So we know that radius over height is 5 over 14. So the radius is simply 5 over 14 times the height. So now we can rewrite our original volume equation in terms of only height. So volume equals pi, and then this is r squared times height over 3. Now I'm gonna skip a few steps and I'm just gonna rewrite this equation simplified. So volume equals 25 over 588 pi height cubed. And now from here, we can just simply differentiate this equation and then plug in the values. So to differentiate, we simply do this pi, and then the derivative here of h cubed is going to be 3h squared times h prime. Again, I'm going to skip a few steps and simplify it. 96. And then at this point, we can simply plug in, since we know this, which is 2, and we know this, which is 6. Which will give us the answer of negative 98 over 225 pi, which is negative 0.13 feet per hour. So that is the rate of change we were looking for, and that is our final answer. So once again, this problem seems like a lot at first. It just takes a few steps you need to follow, but once you figure it out once, every single related rates problem becomes very similar and very simple. So that's it. For more tutoring, make sure to check out our webpage at ase.tamu.edu. Thank you.